All right, we are going to talk today about networking models. So, what is the purpose of a model? A model anything besides a model human. The purpose of a model is to aid in understanding. The purpose of model airplanes is to have fun and build a tiny airplane. But the purpose of our networking models is to aid in understanding what goes on inside of a network and to simplify the creation of protocols and to simplify the creation of networks and new networking technologies. So the two primary models that we're going to talk about, the first one is the OSI model, and it has 7 layers: application, presentation, session, transport, network, data link, physical. And the second model that we're going to look at, and the primary one that we're going to focus on now and in other videos, is the internet model, the TCP/IP model. They have different names. A lot of them have slightly varied definitions for things and slightly different names for the layers. But for the most part, it comes back to the TCP/IP model or the internet model, and I will use the two terms interchangeably. And that is a 5-layer model, including application, transport, network, data link, and the physical layers. Now, if you'll notice, compare between the OSI model and the internet model, the main difference is that there is one big fat layer in the internet model that is comparable to the top 3 layers in the OSI model. And there are a few different reasons for that. We're not going to go into specifics here, but I find that the TCP/IP model is a little bit simpler, and it represents everything that we need to know when we talk about networks. So the important thing to note about both OSI and the TCP/IP model is that they're separated into layers, and each of those layers has their own stuff, their own protocols that take place there. Each layer also provides their own addresses, and we'll talk a little bit in the rest of this video about what kinds of addresses we see there. They each have their own what's called a PDU, or Protocol Data Unit, and that's basically what data is called at that layer. And again, you're going to see, you might see if you Google it or Wikipedia, search Wikipedia, you're going to see slightly different definitions, slightly different names for protocol, for PDUs at each layer. But when it comes down to it, each layer has its own PDU, and that's what you really need to know. And a very important thing is encapsulation. After we talk a little bit about each layer, we'll talk about what encapsulation means in terms of the TCP/IP model. So the top layer, remember, is the application layer. That's really the layer that networking applications interact with. For example, email, BitTorrent, IRC, your web browser. All of these are networked applications, and they each have their own protocol or set of protocols for use at the application layer. For example, email uses SMTP and POP or IMAP to send and receive emails. BitTorrent has its own protocols. IRC is a protocol, and the web uses HTTP, the beginning of the web address. HTTP stands for Hypertext Transfer Protocol, or transport. I can never remember which one. Hypertext Transfer or Transport Protocol. And HTTPS, or the Secured Hypertext Transfer Protocol, is the name of that protocol. And that's, in addition to being the application layer, or the layer that applications interact with, that's also the layer that we interact with, that you interact with when you use a networked application. And here, you may or may not have a separate address. So email, for example, has a separate address at the application layer, your email address. Other applications may not have their own address for the application layer. The transport layer comes next, and the transport layer, like it says, handles connections between applications. And there are 2 primary protocols used at the transport layer. There is TCP, the Transmission Control Protocol, and the PDU in the TCP is called a segment. And there is UDP, the User Datagram Protocol, that calls its data datagrams. And the addresses used in the transport layer is a port. So different applications use different ports. For example, HTTP by default and by convention uses port 80. Now you can configure a web server like Apache or Nginx or any web server to use a different port, but by default HTTP is going to be using port 80. HTTPS uses port 443 and SMTP uses port 25. Those are the addresses for each application at the transport layer. Next comes the network layer, and the network layer provides routing. Routing is what makes the internet work, because without routing, you would not be able to connect from one network to another network. You would still be able to have a local network, for example, within a building, within an organization, but without routing, you wouldn't be able to connect from one network to the next, which means there would be no way for you to connect from your computer at home, to the internet, to Google, for example. If you wanted to connect to Google without routing, you would have to dial in to Google servers directly and connect that way. With routing, you just connect to this great worldwide network and you can get anywhere that you need to go because the protocols sort that out and figure out where traffic needs to go, and they get it there. The primary protocols at the network layer are IPv4, Internet Protocol version 4, and Internet Protocol version 6. And later on, we're going to spend a lot of time talking about the differences between IPv4 and IPv6, and you'll get a lot of stuff there, but that's for a different day. And because IP is the protocol, IP addresses is the address used at that layer. And the PDU is called a packet. So at the transport layer, we had PDUs that were called either segments or datagrams, depending on whether you use TCP or UDP. At the network layer, all of them are called packets. At least all Internet Protocol datagrams are called packets. Now there are other protocols that operate at the network layer besides IPv4 and IPv6, but we're not talking about those right now. Next up, second to last, we have the data link layer. Now the data link layer is primarily the middleman between the network layer and the physical layer. And that's its biggest job, is to control access to the physical layer. In fact, one of the main protocols at the data link layer is called MAC, Media Access Control. In other words, controlling access to the medium, the physical medium that we're using to communicate. The data link layer also provides error checking. It's going to make sure that everything works. It doesn't do anything to correct for errors. If it detects an error in something that it receives, then it throws it away and doesn't pass it along to the other layers. So primarily at this layer, it uses what's called a MAC address. And again, we'll talk in depth about each of these layers. But for now, it's sufficient to know that the data link layer uses the MAC address, and that's the address, and each device has its own MAC address that it uses to communicate between devices on a network. And the PDU at this layer is called a frame. So MAC address and frame are the address and PDU name at this layer. And finally, we have the physical layer. The physical layer is, as far as I'm concerned, the magic that makes it all work. At the physical layer, we've got wires, like your Ethernet cable or your coaxial cable if you've got a cable modem. And we've got waves if you want to use wireless internet, such as Wi-Fi or your cell phone. Then you're going to be using, instead of wires and electricity going through wires, you're going to be using radio waves to communicate. And the physical layer, there's all sorts of different things that go into that, including the connectors. How do devices connect? How do these wires connect? What wires touch what other wires? And there's no addresses at the physical layer, none at all. All that's handled by the data link layer. But there is a protocol data unit, and that is called a bit. Essentially, it comes down to how does the physical layer transmit ones and zeros. And that's really it for those layers. So the magic. So if we have these 5 layers, the application, transport, network, data link, and physical layers. So for example, if you wanted to send a photo from one computer on your local network to another computer on your local network, there's no routing involved, and you're essentially going to be talking directly to the other devices on your network. And the way that that happens, essentially the way this happens is that your photo up at the application layer is going to be using some sort of protocol, for example, the file transfer protocol, to be sent from one computer to another. And the file transfer protocol up here at the application layer is going to send the photo to the transport layer. And the transport layer, again, we're going to go into super depth in other videos about what the transport layer does. But the transport layer is going to chop that photo into segments. And each of those segments is going to get their own information. And each of those segments is then going to be passed down to the network layer. And the network layer is going to add its information. In this case, the addressing at the network layer is the IP address. So it's going to add IP address information to at the network layer, and then pass that further down to the data link layer. And the data link layer has its own address, the MAC address, and we'll add the MAC address to those on top of the IP address that the network layer added, on top of the ports that the transport layer added. And then once we have those data all packaged up into frames, we'll pass that along to the physical layer, which converts all of that information into the ones and zeros, the bits that go across the wire. This is a wired network. And then that information goes across the network to the receiving end, the physical layer on the receiving end. And then all of that happens again in reverse. The physical layer passes that information to the data link layer. The data link layer unpackages each of those frames, pulls off the MAC address information, then passes it up to the network layer. The network layer strips off the IP address information, passes it up to the transport layer. Transport layer strips off the port information, takes all of the different segments that we had and reassembles them back together, and then passes the finished product back up to the application layer, where you have your photo on the receiving end. Now the trick here is that actual communication is really only happening on these arrows between these devices. This is the physical passing of information between layers. However, we do have virtual communication happening from one application layer to another. So the photo that we sent here is being communicated to the application on this end. The segments that are created here are being received by the transport layer on the other end. And that is the magic of these layers. So by splitting up and forcing networking to work in this way, we're allowing communication to happen. So let's look at a larger example. For example, if we did have a router in between, or in an extra larger example, if we had several routers in between. If you are the source and Amazon is your destination, there's going to be several routers that happen in between. Now, if you'll notice, the routers don't go all the way up to the application layer. We still package up everything all the way down to the physical layer, send that information to the router, which is your access and handles access across networks. Now, the router is going to receive those bits from you, and it's going to pass those bits because the physical layer is dumb. The physical layer doesn't know how to do anything. So it's going to pass those bits up to its own data link layer to do what the data link layer does, check for errors and control access to that medium. So it's going to check those, and it's going to pass the frame up to the network layer where it's a packet, and the network layer, part of what it does is handle routing. So it's going to say, okay, where is this packet trying to go, and how can I get there? And it will forward that packet, packaging the packet back up into a data frame, back down to bits, and it will forward that packet to the physical layer on the next spot along the line, all the way through the destination. And you may go through one router, you may go through 5 routers, you may go through 20 routers.
to get from source to destination, but that's just the same process over and over again, going from physical to data link to network to data link to physical to data link to network to data link to physical, etc. all the way across. So one router here on our screen is sufficient to really show kind of what happens. So all the way down, across to the router on the physical layer, because all actual communication has to happen at the physical layer. Back up, back over, down, across, and then finally, when it gets to the destination, then the application layer can receive that information and see kind of what's going on. Now we still have virtual communication from application layer on the source to application layer on the destination. Even though it's getting packaged and repackaged down here at the data link layer and the network layer, the application layer data doesn't change. Same goes for transport layer. We're not going through the transport layer to do routing, so all of that information stays exactly the same, and essentially you're communicating directly with the transport layer on the destination. Network layer gets a little bit fuzzy. There's a little bit of communication between you and the router, and there's more communication between you and the final destination. The data link layer, again, when we talk specifically about the data link layer, we'll show exactly what we mean by that. But the data link layer actually is communication between source and middleman. So you're not communicating at the data link layer between you and the destination. And the physical, obviously, is only between individual devices. So encapsulation. Encapsulation is one of the beautiful things about a networking model like the TCP/IP model. And what it really means is that you're isolating responsibilities to a single layer. And you're allowing for different protocols at each layer. So we talked about a bunch of protocols that can happen at the application layer. HTTP, IRC, email, games, all sorts of different protocols that use the application layer and that make up the application layer. And we talked about two different protocols that take place at the transport layer, TCP and UDP. And both of those are independent of each other. And you can actually use almost any of these. You can use HTTP over TCP or UDP. Most of the time, you're going to use TCP for HTTP, but you don't have to. You could potentially use UDP. You don't, but you could. Same goes for IRC. There are games that use TCP. There are games that use UDP. There's no laws governing what transport layer protocol you use for which things. Each of those protocols is used for different purposes. Again, we'll cover that later. Same goes down to the network layer, IPv4 and IPv6. And the beauty is these are completely independent of each other. You can use IPv4, you can use IPv6, and TCP and UDP don't care. HTTP doesn't care. IRC doesn't care what protocol is being used at the network layer. All that matters is that the network layer is doing what the network layer is supposed to do, which is especially routing. Again, down at the data link layer, we've got different protocols for controlling the data link layer. Ethernet, Wi-Fi. Your web browser doesn't care whether you're connected to the internet via Ethernet or via Wi-Fi. It doesn't have to change anything in the way that it operates. Ethernet and Wi-Fi, the data link layer protocols, handle everything at those layers and make sure that things happen the way that they should, and they take care of their business. And then again, at the physical layer, if you're physically connected, you're going to be using volts. You're going to be using voltage to transmit ones and zeros over a wire. If you're using a wireless medium like Wi-Fi, you're going to be using radio waves. And again, TCP doesn't care whether the data is being transmitted via electrical signals or radio signals. It's only handling its own thing. And the beauty of that encapsulation is that each of these layers does its own thing and doesn't worry about the rest, which is what makes it so simple to swap things out. For example, we're now going through a change from IPv4, an older protocol, to IPv6. And it's a new protocol, a new version of the internet protocol that has a whole bunch of stuff about it that's different. But thanks to this encapsulation, the rest of the protocols aren't bothered by the switch from IPv4 to IPv6. The only thing we really have to worry about is the network layer and how the network layer handles that transition. So that's it. We've talked about the OSI and TCP IP models. We talked about the different layers, the application, transport, network, data link, and physical layers. And we've talked about some of the benefits of encapsulation. So that is all. Thank you very much.